this video, we'll discuss implicit differentiation. Given the relation between x and y, this is the equation x squared plus y squared is equal to 1. When represent using the graph, the graph is a unit circle. And then we try to find tangent line for this graph. This is tangent line for the graph. And then the tangent line is a gradient or slope or dy dx. Dy dx. To find dy dx from the equation, maybe for explicit differentiation, you will write y is equal to third 1 minus x squared positive, or y is equal to negative third 1 minus x squared. This is explicit differentiation. Let's say if you're going to find this one, dy dx, from this given equation, we need to apply chain rule. We need to do implicit differentiation. Apply chain rule. Chain rule is something about this. Given that this one is a function consists of variable y, and we need to differentiate this function with respect to x. Now we need to use chain rule. So this one differentiate this function with respect to y, and at the same time we need to add dy dx. This one is a chain rule, something about chain rule. So we need to differentiate x squared plus y squared is equal to 1 by taking dx to the both side. Just write down x squared plus y squared is equal to 1. Differentiate separately. X squared, y squared, 1. For this part, x squared, differentiate x squared is equal to 2x. But differentiate y squared with respect to x. This one something about you need to use chain rule. Chain rule. Need to use chain rule. That is differentiate y with respect to y. And at the same time, you need to add dy dx. This is something like chain rule. And it's equal to differentiate constant. Answer is now we're going to find to differentiate this one. This one is term. So 2x plus 2y and dy dx cannot be cancelled. And then we're going to find dy dx. Dy dx is equal to negative 2x over 2y. And the answer is negative x over y. This one we call implicit differentiation. Let's say given that xy is equal to 1. Here is also xy is equal to 1. Here you want to differentiate to find dy dx explicitly. Now take y as a sub. And rearrange. Now we need to differentiate with respect to x. So y x power 1. Differentiate y with respect to x. Answer is dy dx cannot be cancelled. And this one is this power rule, negative x to the power negative 2. The answer is negative 1 over x squared. Now we're going to apply implicit differentiation to find dy dx. Here actually two terms. You need to use product rule. U and V. So U is equal to X, V is equal to Y. So here we need to differentiate U with respect to X differentiate v with respect to x. Okay, now here is u x v y. So differentiate u respect to x, get d u dx cannot be cancelled. Differentiate x with respect to x, 1 dx over dx is equal to 1. Okay, and then dv over dx cannot be cancelled. Then this one is dy over dx. Now the product rule, okay, is y is equal to uv. Y prime is equal to u prime v plus uv prime. Okay, since this one just involve u and v, this part, just take this part. Okay, just take this part. Okay, just take this part. Okay, so now that one is, okay, cross multiply. This is du prime times v plus u times dv dx. Okay, and then 1 times y plus x times dy dx is equal to, okay, is equal to differentiate here, okay, actually constant, constant differentiate is equal to 0. Okay, and the next step is, okay, write this one, negative y, and therefore dy dx is equal to negative y over x. Actually done, you may stop here, but if you want the answer same like this one, explicit differentiation, just replace y. So given y, xy is equal to 1, okay, and y is equal to 1 over x, then substitute, and you get 1 over x squared, same like this one. Okay, so on the, okay, this one there is explicit differentiation. This one is implicit differentiation.